Welcome back everyone to another video in our Calculus 1 series. In this video we're going to talk about the limit of a function. This is an introduction to notation on the limit of a function. My name is Ahmed and let's get started. So the limit of a function. When we're talking about the limit of a function, we're going to first talk about the overall notation for the limit, which is defined as this here. And there's different parts of this, where this LIM signifies the limit. So this LIM signifies that you have a limit. This X with the arrow A signifies the X value the limit approaches. So this X with the arrow A signifies X approaching A, where A is the X value the limit approaches. F of X is our function, and L is where the function approaches as X approaches A. So the value the function approaches as X approaches A. We can say the value here because this is a number. So where the function approaches as X approaches A. And this is the overall notation for a limit. From this notation, this splits up into the three terms. Limit as X approaches A of F of X. The limit as X approaches A with this negative sign of F of X equal to L. And the limit as X approaches A with this positive sign of F of X is equal to L. Well, what do these three things mean? This one we already talked about. This is the limit as X approaches this A value of our function is equal to L. Now we get here and we have the same thing except we have this negative and this positive in the exponent of A. What does this mean? This means we're taking the limit from the left side of A. This we call a left-sided limit. And the positive in the exponent is called a right-sided limit. And we'll make more sense of these when we do the problems. But for now, you should understand that A is including the left side of A and the right side of A. So if I give you the limit as X approaches A, you can imply that the left and the right-handed sides are already incorporated in that. And what do we say the overall notation for that is? We say the limit as X approaches A of F of X is equal to L if and only if, and this is very important, this is a conditional statement, meaning the limit as X approaches A of F of X is only equal to L if the left-handed limit is equal to the right-handed limit. And they're both equal to L. What does that mean? It means that this term is equal to this term. When the left and the right are equal, then you can say the limit as X approaches A of F of X is also equal to this L value. And so this is a theorem you should be aware of in this chapter. The limit as X approaches A of F of X is only equal to L if and only if the left-handed limit and the right-handed limit are both equal to L. This means from the left side of A, this means from the right side of A. So on a number line, if I give you A, the left-handed limit is taking any value very, very, very close to the left side of A, and the positive means any value close to the right side of A. The last thing we're going to talk about is two things for notation. The first thing is where the value of the limit does not have one. Value or no value for the limit versus no value for a point. So if I give you a problem that has the limit as x approaches a of f of x, and you get to give me the answer, and you find that there's no value, there's no L, there's no value for that limit, what are we going to say, or how are we going to signify that? If there's no value for the limit, whether it be graphically or algebraically or any sort of limit you calculate, we're going to say that the limit does not exist, or the shorthand D&E, which stands for does not exist. Versus, if there's no value for a point, let's say I tell you I want the value at x equals 2 of my function, or f of 2. You're going to say that the point is undefined if there's no value for your point there. The point is undefined. This is a very, very important concept. If there's no value for the limit does not exist. If there's no value for a point, the point is undefined. So this is an example if I give you f of 2 and there's no value, versus if I give you the limit as x approaches 2 and there's no value. And these two things are not interchangeable. So if you're asked for a point like f of 2 and it's not there, you say undefined. If you're asked for a limit like this one as x approaches 2 and it's not there, you say does not exist. And these two things are not equal to each other. So just watch out for that while you do these problems. That's it for the notation on the limit of a function. In the next videos, we're going to tackle on problems graphically and algebraically that involve this notation. So we'll see you in the next one.